the Pythagorean theorem and its converse. So we want to use the Pythagorean theorem to find a missing leg or hypotenuse, and then use the converse or the Pythagorean inequalities theorem to determine if a triangle is right, acute, or obtuse. So first, if a triangle is a right triangle, then the sum of the legs squared and the other legs squared is equal to the hypotenuse squared. So when you're looking at a right triangle, understand that across from angle A is going to be a leg, and we're going to call that side A just because it's across from angle A. The other leg makes up the other side of the right triangle, and we're going to call that side B. Really, side A and B are interchangeable. They're just the legs that create the right angle of the right triangle. The one that never changes is your hypotenuse. And your hypotenuse is always going to be represented by C. It is across from the right angle, and it is the longest side. So when I say across from the right angle kind of points at your hypotenuse. But it is always represented by C in your Pythagorean theorem. So let's look at a few examples. We want to use the Pythagorean theorem to find the missing length of x. So notice this is my hypotenuse, so this is my C value. And then the other two sides are A and B, respectively. So then when we set this up, we're going to say x squared plus 16 squared is equal to 34 squared. So now I know that x squared is equal to 900. And we will take the square root of both sides, because the square root of x squared is going to give me my x value, and then the square root of 900 gives me 30. So that side A that we labeled up before, x equals 30. Go ahead and try B and C. In B, you're looking for your hypotenuse, and in C, you're looking for a side length, but your hypotenuse is 10, so that's going to be your C value. Make sure you've got everything set up. And you always want to put it in simplest radical form. So this one should be 3 root 13 and this one should be 5 root 3. Let me know if you have any questions on how to get those two answers. Alright, moving on. Pythagorean triples are special types of combinations of triangle sides. They are 3 integers, meaning whole numbers, that are positive, that always work in the Pythagorean theorem. And by always work, I mean you never have to deal with 3 root 13 or 5 root 3. It gives you a nice whole number all the time. So if you're trying to determine if something is a Pythagorean triple or not, you're always going to plug in the biggest number for C. Why would you do that? Because the hypotenuse is always the longest side. So the most common Pythagorean triples are 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Now if you want to find more Pythagorean triples, you can multiply any of these triples by the same positive whole number and you'll produce more sets. So for example, if you wanted to find a Pythagorean triple, if you multiplied each one of these by 3, 15, 36, and 39 should also be a Pythagorean triple, meaning that 15 squared plus 36 squared equals 39 squared. So that's the concept of Pythagorean triple. So if we want to determine if each set of numbers is a Pythagorean triple, then all you're going to do is plug in the biggest number for your hypotenuse value. So this would be 9. And so the question is 9 squared equal to 7 squared plus 8 squared? If it is equal, then they are a Pythagorean triple. If it is not equal, then they are not. And in this case, you get that 81 is 9 squared, and 113 is 7 squared plus 8 squared. So since those are not equal, this is no, not a Pythagorean triple. This one is also not a Pythagorean triple because my biggest number is 38, so that's going to be my quote-unquote possible hypotenuse, and 38 squared does not equal 21 squared plus 28 squared. This third one is the only Pythagorean triple. And if you plug in 25 squared, because notice 25 is my hypotenuse, so that's what I want to use, 15 squared plus 20 squared is equal to 625. And 25 squared is also 625. So therefore, these two are equal, so they are a Pythagorean triple. Now, what does it mean if you use the Pythagorean theorem and you don't get something that is equal, like these two examples A and B? Well, if c squared equals a squared plus b squared, then we know that we have a right triangle. And we know that c is going to be 90 degrees. But if c squared is less than a squared plus b squared, then the triangle will be acute because c will be less than 90 degrees. Angle C is less than 90 degrees. And if c squared is greater than a squared plus b squared, then the triangle will be an obtuse triangle, and C will be an angle that is greater than 90 degrees. So, if it's equal, C is 90. If it's less than, C is less than 90. And if it's greater than, then C is greater than 90. All right. In example 3, you are to classify each triangle by the number, by its sides. So again, your C value is always going to be the largest number. And you want to determine how is 4 squared plus 5 squared related to 6 squared. Is it greater than? Is it less than? Is it equal to? So 4 squared plus 5 squared gives us 36. And 6 squared also gives us 36. These two things are equal. So then this is a right triangle. All right. Let's look at letter D. The square root of 17, the square root of 16, and the square root of 11. So this is going to be my hypotenuse. And the square root of 17 squared gives us 7. And the square root of 11 squared gives us 11. And the square root of 16 squared gives us 16. So I have 18. And how is that related to 16? Well, 18 is bigger than 16. So because my C value is less than A plus B, this triangle is acute. Try the other two on your own, and then make sure you ask me any questions.